Consider the another fluid property. There is a vapor pressure. It is denoted by P suffix V. Consider this is a closed container and in that the water is filled. After some time, the molecules from this free surface of water they goes to into the space and gathers there in a lot of proportion and they exert a partial pressure on this free surface of the liquid. So that is why it is called vapor pressure. Vapor pressure is generally function of temperature, means as temperature increases vapor pressure increases. Like mountains, the uh, boiling of water is at low temperature. So when impressed pressure less than equal to vapor pressure, then cavitation may occur in a hydro machinery such as turbines, pumps. There is a impressed pressure is less than equal to vapor pressure less than equal to vapor pressure. When local atmospheric pressure is less than equal to vapor pressure, then cavitation phenomenon occurs. So due to cavitation, erosion, pitting, vibrations are created. So this is the vapor pressure property. The next is cohesion and adhesion. Cohesion means molecular force of attraction between same molecules of fluid is called cohesion, and adhesion means molecular force of attraction between dissimilar molecules is called adhesion. Let us see a mercury which is spilled on a floor, so it gathers into the droplets having theta greater than pi by 2. So this is the condition of non-weight, non-weight, non-weighting condition. This is a mercury. Like when water is spilled on a floor, it gives a theta less than pi by 2. So the water uh, does not behave like mercury molecules. So spreading of water is there, theta less than pi by 2, and it weight the surface. Hence this is called weighting condition. Weight, weight of water, weighting of water. The next property is capillarity. Capillarity, suppose there is a container, water is filled in a container, and a tube less than 12 mm, when it is inserted into this water bath, the surface tension, so this is a rising of water having a height h, and this is the surface tension force by sigma pi d cos theta. So this surface tension force is balanced by height of water h in a tube. So these two forces are in a equilibrium condition. Sigma pi d cos theta equal to rho g into v. So sigma pi d cos theta equal to rho g, volume is pi by 4 d square into h. So here pi d get cancels and we get h is equal to 4 sigma cos theta upon rho g d. This is the required expression for capillary rise. Similarly, when mercury is used, instead of rise it get depresses due to cohesion property. So for pure water, theta is equal to 0 degree, pure water. And contaminated water, theta is 25 degree. Contaminated water. And for mercury, it is 128 to 130 degree for mercury. And next property is surface tension. It is measured by Newton per meter. Consider there is a container, and in a container there are three molecules A, B and C. Let us take a molecule A, which is acted by in all directions. So resultant force acting on molecule A is downward direction, whereas molecule B, whose a major portion is in the liquid, and it is acted upon by a downward force. Net resultant force is in downward direction. Consider molecule C, whose a half part is in gas and half part is in liquid. So such a molecule having a net resultant force in downward direction. Hence force per unit length is called a surface tension. Surface tension is depends on temperature. As temperature increases, surface tension decreases. The next property is compressibility. It is denoted by C, which is equal to the reciprocal of bulk modulus of elasticity K. For liquids, the bulk modulus of elasticity is very small. Hence, for all practical purpose, the liquids are considered as incompressible. Similarly, gases, when Mach number less than 0.3, it is considered as incompressible. Next is fluid. Fluid is categorized into two parts, Newtonian fluid and non-Newtonian fluid. In a Newtonian fluid, there is a air, gasoline, water, kerosene, etc. These are called time independent fluid. Whereas in a non-Newtonian fluid, there are two types, time independent and time dependent. In a time independent fluids, there is a dilatant fluid, pseudoplastic fluid, Bingham plastic fluid. Whereas in case of time dependent fluid, there is a thixotropic and rheopectic fluid. Thixotropic means the increase in viscosity with time, apparent viscosity with time, and rheopectic fluid means decrease in apparent viscosity with time. Here, the graph between a Newtonian fluid and non-Newtonian fluid is shown. On x-axis, we have taken du by dy, velocity gradient, ideal fluid, and on y-axis, we have taken shear stress, ideal solids. A line passing through this origin is gives the Newtonian fluid. A line which is n greater than 1 gives dilatant fluid. There is a general relationship, tau is equal to a du by dy raised to n plus b, where n is a power of the velocity gradient. So n is greater than 1 for dilatant fluid. Dilatant fluids are butter, quicksand, etc. There is a pseudoplastic fluid having power n less than 1, gasoline fluids, uh, certain paints, enamels, etc. And Bingham plastic, sewage slug, drilling mud. These are the example of this Bingham plastic. For Bingham plastic, B is equal to tau I, means some yield trace is required. Thixotropic fluids means those fluids which increases, apparent viscosity is increases with time, and rheopectic fluid means the decrease in apparent viscosity with time. The bentonite solution, gypsum suspension, and solutions. These are rheopectic fluid. Thank you.